Namaste and welcome back to the JavaScript series. Today, my dear friends, we are going to explore probably one of the most important concepts that you're ever going to learn in this beautiful programming language called as JavaScript, which may literally make or break your career, your proficiency, and how good or bad a JavaScript developer you're going to be. And without any more suspense, the name of the concept is called as asynchronous JavaScript. Now, if you don't know what is asynchronous JavaScript, how to write asynchronous code, how to write non-blocking code, then trust me, you'll not be able to develop the kind of modern day web applications that is designed using JavaScript. So anyways, first in order to understand what is meant by asynchronous JavaScript, first you must understand what is meant by synchronous JavaScript. Only if you understand synchronous, asynchronous will make sense. Now, what do you mean by synchronous? Let me explain. Synchronous JavaScript in simple words means line by line execution. The way JavaScript has been designed is, if you write code, it will always execute the code one line at a time. Till that one line completely finishes execution, it will never proceed on to the next line. Now, what do you mean by that, you may ask? Seeing is believing, so watch it. I'll just bring up my editor here for your reference. Now, on the editor, I'll just go and write one simple piece of code, okay? For example, let A equal to, say, 10. Next, let B equal to 20. Next, I will say, let result equal to probably A plus B, like this, okay? After which what I'm going to do is, I'll just print my result by telling console.log result, and of course, console should be C in lowercase. This is great. Now, what are you trying to explain through this, you may ask? Now, the way JavaScript is designed is, it is designed to execute synchronously. So please try to understand, this code when it executes, it starts from the top to bottom. Now, the first line of code executes, right? In which case, we create a variable called as A, and inside that we store a value called as 10. Now, unless until this line completely finishes execution, please try to understand, until this line completely finishes execution, it is not going to go to the next line. That's the meaning of synchronous. Now, the next line executes, in which case we create a variable called as B and we initialize it with 20. Now, while this line is executing, this won't execute, they will have to wait. Synchronous, line by line. Now, in the next line executes, assignment, right hand side, A plus B, 10 plus 20 is 30. Take that 30, create a variable called as result and assign it. Then the last line executes, wherein I'm going to be printing the value of result. It gets printed on the screen. And then execution stops. This is synchronous, line by line, one line at a time, sequential. While one line is executing, the other line will not execute. The JavaScript engine will wait for the line to execute completely and only then move on to the next line. This is synchronous, right? And if I were to now just go and execute this code for you, yes, we saw 30, which is the result, right? Great. Now, is this a problem? Is this good? Is this bad? See, programming is not black and white. It is gray. It's not as simple as, what is good, bad. It doesn't work like that. Synchronous form of execution has its own benefits, right? What it is, we will explore. But let me make this example a little bit more complicated, so then you can start to understand certain pitfalls or problems or issues which start to occur when your code is purely 100% synchronous. What do I mean by that? Let me show you. Now, my friend, in order to understand the disadvantage of the synchronous style of execution, I'll give you an example, okay? So let us assume we have three tasks. Okay? Every task is independent of each other. What I mean to say is, one task doesn't depend on the other. The execution of this task doesn't depend upon this task. They are independent, okay? Like this, I'm going to create three tasks. Try to understand. What I'm going to do now is, I'll just go back to my editor, and here, every task will be its own function. So I'll create one function. I'll call it as task1, just for your ease of understanding. Now in this, I'll just have a message, console.log, right? Wherein I'll say task 1 started. So that when this message appears on screen, you know that it has started, right? Now, please try to understand. What I also want to do is, between it starting and completing, let us assume this task is going to take some time. But if I were to execute this code, it will literally execute in a fraction of a second because there is no delay here. It's just an example I'm trying to give. It's not an actual task. So I need to artificially induce some delay. Now, how will you artificially induce some delay? Try to understand there are various ways to do it. The easiest way to do it is, I'm going to create one variable called as start. Now, what should be inside this variable? Inside this variable, whatever is the current time of my machine now. Whenever I'm recording this video, right now I'm recording it, right? There is some time. Whatever is the current time on my machine right now, I want to fetch it, right? So how are we going to fetch that? There is one easy way. The easy way for you to do that is, there is something called as a date class. Inside that, there is a built-in function called as now. There is a built-in function called as now. What this now does, all that I will explain to you, but just try to understand. Read this for example. It returns the number of milliseconds that has elapsed since the midnight of January 1st, 1970. So from January 1st, 1970, up until this very moment where I'm recording this video, how many milliseconds has passed? That it will give me. Understood? Now, how is this going to help you, you may ask. Try to understand. What I'll do is, it's a function, so obviously parenthesis is required. All right? So let me, if I were to print this, you will get a huge value. I'm not going to show that because it's in milliseconds, and those of you who don't know how to sort of conceptualize milliseconds, 1 second is 1000 milliseconds. 2 seconds is 2000 milliseconds. 7 seconds is 7000 milliseconds. That's it, right? So 1 second is 1000 milliseconds. Keep this in mind. Now, what I want to do is, let us assume I want this task to take 5 seconds. So the delay that it is going to cause is 5 seconds. So what I'll do is, I'll create a variable called as delay, inside which I will store the delay that I want, again in milliseconds, which is 5000. So please try to understand, from January 1st, 1970 up until now, this will give me in milliseconds, right? Now, to that time, if I add 5000 more milliseconds, that is like 5 seconds. If I add 10,000 milliseconds, that is like 10 seconds, right? So whatever is there in this delay, this number, if I add it to this, that will give me how many seconds I need to wait for. Because from start, I'm adding some, and that is my end, right? So what I'll do is, I'll just go here, create one more variable called as end. And to end, what I will do is very simple. I'll take whatever was the start time, to that I will add the delay, right? So start will give me the current time. To that, if I add 5000, it's like 5 seconds. 10,000 is like 10 seconds. Now what will you do with this? Now very simple. I will run a while loop. And those of you who have been attending these classes regularly, you know that how you have to read a while loop is as long as this particular condition is satisfied, I'll keep performing an action. And what is that condition? That condition is, hey, listen, the current time, right? Every time I will fetch the current time and I will check if it is lesser than the end time that I have calculated. If it is lesser. How will you do that? How will you get the current time? Date.now. Now I'll check, is date.now lesser than or equal to whatever I've calculated as the end time. So when this code executes, I'll get the current time. To that I'll add some delay and I'll get an end time. Then again I'll fetch the current time because time is continuously moving. I'll check whether the current time now is lesser than or equal to the end time. And till it is lesser than or equal to the end time, this loop will keep executing. So if it is 5 seconds, it will wait for 5 seconds. If it's 10 seconds, it will wait for 10 seconds. It's a simple way to create some delay. Inside this, I will not do anything. It's empty. It's just artificial delay. Now try to understand. I just want one message. So I'll just tell console.log start or say I will say task 1 executing like this. So this message comes. Now after this is over, I'll just at the end also go and I will be printing one message. I will say task 1 completed. Do you understand what I'm trying to say? So it's a very simple function, right? Like this, I want to create 3 tasks. So I'll just copy this entire function, and below this I will be going and I will be creating another function, task 2. I'll say task 2 started. Let us assume task 2 is going to take 3 seconds, so I'll say 3000. So now you will getting 3 seconds delay. I'll say task 2 is executing, task 2 is completed. Similarly, I'll go here, paste this again. I will change this to task 3. I will say task 3 started. Let us assume this guy is going to take a total of 6 seconds. I'll say task 3 is executing. I'll say task 3 is completed. So friends, please try to understand. I've just created 3 functions, task 1, task 2, task 3. Each of it is going to take its own amount of time. Now you should understand how this all works. Watch it. A function will not execute on its own. You have to call it, and all this I've explained. So I will first be calling the task 1, right? Then I'll be calling the task 2 function. Then I'll be calling the task 3 function. You must understand, each of these tasks are independent of each other. They really don't have any dependency. But though they are independent, one doesn't have to wait for the other. Still, JavaScript will ensure that when one function is executing, others inevitably will have to wait for it to complete because of its synchronous nature of execution. Now, what do I mean by this? Let me show you from the memory point of view. If you've been attending classes regularly, you know whenever a JavaScript program is executing, on the memory, we have the call stack and we have the heap. The first thing that happens when any JavaScript code executes is the global execution context, or GEC as we call in these classes, gets created. Now, I've spoken of the global execution context in great detail, but I'm not speaking about it, right? Inside the global execution context, all such code which is outside every single function within your program will get executed. And in that you have only 3 lines. In that, when the first line executes, you're again calling one function called as task 1. You're calling this function. Whenever a function is called, what happens? Its own execution context gets created on the stack. This also I've explained. And this is the execution context of which function? Task 1. Now, global execution context is not executing. Task 1 is executing. Which means, please try to understand, JavaScript is synchronous in nature. At any given point of time, only one line can execute. Which means when now this function is executing, no other part of the program will execute. Which means, try to understand, now control comes inside, this first line executes, you will get task 1 is started. Then you will be calculating the current time, you will be inducing a delay of 5 seconds, calculating the end time. Then you will get task 1 is executing, and then now task 1 is now going to be inducing a delay of 5 seconds, then it will complete. Which means this entire piece of code is going to take approximately 5 seconds to execute. Now, while this is taking 5 seconds to execute, I want you to logically think, we have task 2, we also have task 3. Now, task 2 and 3 will execute only if this line and this line executes. Now, these 2 lines will execute only if the global execution context is executing. But the global execution context is not executing because it has been paused. Why has it been paused? Because who's executing now? Task 1 function. Because JavaScript is synchronous, while it is executing this piece of code, no other piece of code is going to execute. And hence, it has knowingly or unknowingly blocked the execution of task 2 and task 3. Though they have nothing to do with task 1, they have to wait for task 1. They have to inevitably wait for task 1, no option. Yes? Now, let us assume task 1 finishes execution. Then what happens? The task 1's execution context gets removed. Control comes back to the global execution context. There we had executed up until this line. Now the second line executes. When it executes, you're calling a function called as task 2. Then task 2's execution context gets created. Now this will take around 3 seconds to execute. While it is taking 3 seconds, task 3 has to wait. Though it has no dependency, it has to wait. Then once task 2 finishes, its execution context goes, control comes back to the global execution context, and now the last line executes. Then task 3's execution context gets created. Then this guy will take around 6 seconds to execute. And if there was any other task, they will have to wait for the task 3 to finish, because JavaScript is synchronous in nature. JavaScript will execute only one line at a time. And when one line of code is executing, no other line of code can execute. And hence it starts forming dependency. It forms a sequential way of execution, also known as synchronous. And whatever I told you now, if I have to show it to you as an output, and also please try to understand, once task 3 finishes, its execution context gets removed, control comes back to the global execution context. In the global execution context, do you see any other statements remaining? No, which means even global execution context gets removed, stack becomes empty, program execution stops. This I've already explained, but try to understand it from the output point of view. See, if I were to execute this, see, now task 1 started, task 1 is executing 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. After that, task 2 started. Now this will wait for 3 seconds, then task 3 started. Now this will wait for 6 seconds. So at any given point of time, only one task is executing. Other tasks are waiting. Synchronous, sequential. Now if this is how applications were built, this would be a big problem for us. Why? I can give you hundreds of examples, but let's start with one example I'm sure all of you can relate to. The best example that I can give you to understand what the problem with synchronous will be is a chat application like WhatsApp. See, please try to understand. In WhatsApp, you can send message, you can receive a message while chatting with a friend. Now, all of you, I want you to visualize how you use WhatsApp. So let us assume you received a message from your friend. You open the chat bubble. Once you open the chat bubble, you can reply to your friend. You can send a message. But while you are busy typing out the message, still your friend's message you're able to receive, right? So you're able to receive messages while sending. Now please tell me, while sending the message, so again I'm bringing two things here. One is send message, one is receive message. While using WhatsApp on a day-to-day basis, while you are sending a message, does it block receiving messages from your friend? Definitely not. While receiving messages from your friend, does it block your ability to send a message? So think logically and tell me, do they follow sequential execution? Does sending have to complete for receiving to happen? Does receiving have to complete for sending to happen? Definitely not. Sending doesn't block receiving, receiving doesn't block sending. Which means clearly they are non-blocking code. They don't block each other. They are independent activities which don't block each other. They are independent activities which don't execute one after the other. Rather, they are happening parallelly. Rather, they are happening asynchronously, not synchronously. I hope you will understand. I'll help you define asynchronous in a much better way, but I hope you got the drift. But if WhatsApp was synchronous, I'll show you how it would look like, right? So to understand this, I have just created one simple demonstration, right? One dummy application I've created just to demonstrate this for you. So now watch it. Right now, let us assume this is WhatsApp. You can, your messages keep coming and you can type out a message. Let us assume I make it into a synchronous mode. Imagine WhatsApp was synchronous. Now my friend is sending messages to me. Yes, I'm able to receive incoming messages. But the moment I go here and start, hi, about the meeting at 5 p.m. The moment I start typing, you can see incoming messages are stopping and they are getting queued in the background. It's not coming here because now sending message is blocking receiving message. And the moment I send, now sending is over. Now receiving will start and one by one it comes. Now while I am getting messages, I cannot send messages. Do you think this is how WhatsApp works? See, the moment now I go and now if in case I were to go here and if I start, that's it. I have blocked incoming messages and they just keep getting queued. I think everybody understood what I mean by synchronous. What I mean by one independent task blocking the execution of another task. What I mean by sequential execution. And clearly you have seen the disadvantage. Like this, I can give you hundreds of examples. Let me give you another example, which is about the application which we have built within TAP Academy so that students can watch their video recordings of the lectures, can practice, can apply for jobs, can take up tests, everything related to interview preparation. We have created our own app for it. Now I'll give you an idea of how the app would behave if it was synchronous in nature. Let me show you what I mean. Now my friends, let me take you to TAP Academy's platform. As you can see, once you log in, a dashboard opens up. Now this dashboard has a banner image where we showcase the different students who have placed through us, different announcements, etc. Below that you can see there is a course progress component which shows how much of the course a person has successfully completed. Beside that, we have something called as an employability score, which basically tells you how employable you are by assigning a quantifiable value to it. To the right, you can see a leaderboard where the most consistent, the most hardworking and talented students automatically bubble up in the leaderboard. Below that, you can also see there is something called as a submission streak, similar to what you see on LeetCode, where you can see which are the days that you have solved questions. We also have something called as a submission streak, etc. Great. Now, please try to understand, if in case I had created this application in a synchronous manner, then please try to understand, while one task is happening on the dashboard, other task has to wait. Now let me show you how it would look. Now let us assume the images have to be loaded in the first component. While images are getting loaded, let us assume the internet speed of the user is slightly less and it takes around 5 to 6 seconds to download all the images from the server and render it inside the browser. Now for 5 seconds while this image rendering is happening, your course progress will not work, your employability score will not work, your leaderboard will not work, your submission streak will not work. In other words, your entire application's UI will freeze. It will become unresponsive. You cannot do anything on the platform. Now once the image gets loaded, now course progress has to go inside the database and fetch the course progress. While this is happening, all other components freezes. Again UI freezes. Next, when employability score is happening, other components will freeze. Now when leaderboard is happening, other components will freeze. In other words, it will be the worst user experience for anybody to use the TAP Academy's platform because it's extremely slow, it is extremely unresponsive, and the UI keeps freezing or stalling. Now, whatever I showed you, if I have to just relate it to the code example that we had just discussed, see, here, let us assume these three tasks, I'll rename them, okay? Let us assume that this first task was the task of loading banner images, similar to what is there in the Thai platform, right? I will just change this task 1 to this, loading banner images. Understood? Let us assume the second task was a task which had to basically calculate course progress. Right? Now I'll just copy this, I'll paste it here, I'll paste it here as well, so that you are able to see a different message here. Let us assume the third task was related to calculation of employability score. I'm just giving you an example. Or let us assume this has to do with render leaderboard. Right? Great. I will also just change the name of task 3 to render leaderboard executing, completed. Now obviously I need to change these function calls as well. So the first function call that I have is loading my banner images. The next task that I have is probably calculating my course progress. The next thing that I will have is calculating my, say, or rendering my leaderboard. 100% these are three independent activities. Loading images has nothing to do with calculating course progress, definitely has nothing to do with rendering leaderboard. But because JavaScript fundamentally is synchronous in nature, it will only execute sequentially. And when that happens, please try to understand, if I were to go and execute this, now while loading images is happening, everything else is frozen. Now after that, when course progress is getting calculated, everything else is frozen. Then when leaderboard is getting rendered, everything else is frozen. Like this, once all the components on the dashboard has been successfully rendered, then the UI becomes responsive. That is definitely not how today's applications are built. And if this is not how you want your applications to be built, then please understand there is a beautiful solution for this, where when one task is executing, the other independent tasks do not have to wait for each other. They can happen asynchronously. And that is why you should learn asynchronous JavaScript. You should learn the event loop. If you understand how to write asynchronous code and from the internals how the event loop works, you will be a next level JavaScript developer, right? So the solution I will discuss in the next video, but I hope the problem you understood. Anyways, please try to understand. In conclusion, JavaScript executes synchronously. If I have to split it into points, the first point is execution happens one line at a time, right? Sequentially. Second thing is that one piece of code will block the other piece of code because it is executing synchronously. This third point is, what is the problem? The problem is it freezes the UI, makes it unresponsive, makes it stall, which ultimately will affect the end user's experience. And this is why they came up with asynchronous JavaScript. Anyways, I hope you enjoyed today's explanation. Next class, I will be teaching you how to actually achieve asynchronous code. Anyways, thank you so much for listening. As usual, if you love the content, make sure to let me and the team know by liking, sharing, and subscribing to the channel. And also just drop down a comment, which I'll read and that'll make my day. See you in the next class. Till then, take care. Bye-bye.